Good afternoon, good morning, good evening to all participants. I welcome you to the CIMAC Circle within the Electric and Hybrid Marine Virtual Life. Our topic today is electrification, hybridization, a solution for every ship type, ? So I'm happy to chair this panel, and the participants are as following. The first one is Marco Thomas from Rolls-Royce Power Systems. He studied electrical and electronic engineering at the Aachen University and the Technical University of Barcelona. He has worked on the development of high voltage systems and batteries for more than 10 years. He started his professional career as a consultant in different development projects for the electric and electronics aspects of high voltage battery systems for BMW and Daimler. In 2009, Marco Thomas joined Audi and worked in several leading positions in the field of high voltage systems and components. Since April 2019, he's working for the Rolls-Royce Power Systems as Director Electrics Electronics Development. He's responsible for the EE component development, including the electric powertrain for rail and marine systems. For example, power electronics, e-motors, and battery system. The next one is Stefan Goranov. He's a program portfolio manager within WinGD with a strong focus on energy efficiency optimization through electrification and digitalization. Having background in electrical engineering with emphasis on the marine and offshore sector, his career began at sea over 18 years ago, culminating in a role as chief electrical engineer aboard a cruise ship. Stefan joined WinGD in 2009 as an automation and control expert, and later he led an R&D team of engineers responsible for the development of embedded systems for machinery control and system integration. Today, leveraging innovative methods and frameworks, Stefan's team develops solutions, advises customers, and executes projects for fit-for-purpose hybrid energy systems in the merchant marine sector. Yaya Björkeli has more than 25 years of experience from the maritime industry. Prior to joining Corvus Energy as CEO in January 2018, he was regional director of the Dutch offshore construction equipment solutions company Huisman. He has also held several executive positions within Rolls-Royce, including VP Sales for Northeast Asia and Managing Director of Rolls-Royce Marine Japan, during which time he was based in Korea for 6 years and Japan for 2 years. He is also a member of the board of Federation of Norwegian Industries Maritime branch and a member of International Advisory Panel on Maritime Decarbonization. Yaya is a mechanical engineer by training from Western Norway University of Applied Science and holds an MBA in shipping, offshore, and finance at BI Norwegian School of Management and Nanyang Technical University, Singapore. Corvus Energy is headquartered in Norway and is the leading provider of energy storage systems for maritime, offshore, subsea, and port applications. Erik Jan Bonen is a principal research engineer in the field of mechanics and systems at the Central R&D Department of Damen. He graduated in 2009 at Delft University of Technology with a master's degree in mechanical engineering. After his graduation, he worked as a researcher at the university and thereafter at Van Oord. He has been working for Damen since 2012 and has worked previously as a mechanical and R&D engineer. System integration, simulation, and sustainable technology are the main themes throughout his career. Last but not least on the panel, it's Morten Veigard-Laursen. He is heading the electrical automation at Maersk, anchoring all aspects from innovation and new build to daily operation at E&A equipment and solutions on vessels. Morten holds a Master of Science in Electrical Engineering and Automation from the Technical University of Denmark. And his past experience at MAN is dominated by R&D within system integration between engines and other equipment in the engine room, such as Tier 3 shaft generators and waste heat recovery. My name is Hinrich Mohr. I from Gaskraft Engineering. I founded my own independent consultancy last year, which is based on the 25 years industry experience with large bore engines, system integration, and field support. In parallel, I'm also acting as a honorary professor at the Technical University of Braunschweig. Yeah, I look forward to the discussions. Here you can see the agenda. We have now nearly finished the introduction by the chair. The slides will come more. Then we will see the keynote and hear the keynote by Morten. We will have some introductory remarks regarding the topics from all panelists. And then we will start the discussion in Outlook 2030 and a Q&A session. Next, please. First, let me start. What is CIMAC? CIMAC relates to the large combustion engine machinery is essential to the global economy, especially in maritime transport, energy, and rail sectors. The International Council on Combustion Engines, where the acronym CIMAC is staying for, was founded 1951 in Paris. Today, CIMAC, as a worldwide non-profit association, is consisting of national member associations and corporate members in 27 countries all around the world. CIMAC covers large engines used for power generation, marine propulsion, and locomotives. The membership includes engine manufacturers, engine users, component suppliers, fuel and lubricant companies, research organizations, classification societies, universities, and other interested bodies all over the world. Within CIMAC, several working groups are active, and one working group is also responsible for today's CIMAC Circle. That's the working group 20, System Integration. This working group is headed by Marco Tömmes from Rolls-Royce Power Systems. He is part of the discussion today. He is assisted by the secretary, Markus Wenig from WinGD, from Winterthur. Then we have, in addition, 3 different subgroups. The subgroup hardware is currently headed by Marco Tömmes as well. Then we have the subgroup tools headed by Robert Strasser from AVL. And the subgroup monitoring is headed by myself. The most important current activities are the establishing of guideline papers, one for monitoring system for marine hybrid propulsion and for virtual system integration. Further on, we are working on an alignment on the hybrid definition. So you see, these are all topics we are expected to discuss today as well. So with that, I hand over to Morten, and we are looking forward to receive your keynote. Morten, the floor is yours.
Thank you, Henrik. Thank you for the introduction and for the overview of the important activities in CIMAC 20. Good afternoon, good morning, good evening, everyone. I'm super excited to be here today and to be able to present on what I consider one of the most important and interesting aspects of maritime engineering today. Electrification and hybridization is something that has also always been close to my heart. As you may know, then I'm part of Maersk, as Henrik introduced earlier, sitting in a function called Fleet Technology, where we are designing the vessels for the Maersk fleet. In previous times, the technical department has been developing tugs, offshore vessels, gas tankers, ro-ro ferries, car carriers, etc. But in the end, container vessels, that's what we are doing most today, and that's also where I'll be focusing my presentation. So the theme of today was electrification and hybridization, a solution for every ship type. And for container vessels, that might not be the most, you can say, suited vessel for hybridization. Container vessels have a very smooth operating profile, where hybridization usually is suited for intermittent or changing loads. But you could also put it another way: if it's relevant with hybridization and electrification of container vessels, then it might suit everyone. So let's see after the presentation how it is, where container vessels stand here. The current situation in the container industry is that we have kind of a bipolar setup for electrification and hybridization. There's some very small vessel, barges. Yara, Asku has some demonstration projects on, and also ro-ro ferries that are operating on batteries as the sole energy source. And in the other range, for the very large vessels, we have for many years have the shaft generators and waste heat recovery systems, as I also consider as part of hybrid systems. And I would say the batteries are coming into that field as well for spinning reserve. So what I'm going to cover today is that that's the situation, and in the future, will we then close the gap? Will this be a solution for all container vessel types, and will we accelerate the use of these going forward? So first of all, I'll touch upon some of the drivers to close this gap. First off, we have sustainability. It's no secret that Maersk wants to take a leading role in the decarbonization of the shipping industry, and sustainability is part of that. And with that, we realize that there are some synergies between decarbonization and electrical and hybrid systems. First off, of course, to the extent that you can use electricity directly, then there's an opportunity of having a clean power source. But what perhaps is more important is that when if we have carbon neutral fuels for deep sea shipping, be that methanol, be that ammonia or others, then so far prices looks to be coming in at a premium compared to normal traditional fuels. And a premium fuel price means that you can say the motivation to aim for energy efficiency is higher. There's simply just a better payback, and that's where, in my mind, the hybrid solutions come into play first and foremost. This is another important part for regarding hybridization is that we've been looking at energy efficiency for vessels for many years now, but mainly looking at the propulsion side. But now we're also looking at the auxiliaries to a higher extent, and hybrid systems and electrifications obviously play a larger role in that setup. Last but not least, I want to highlight a specific point about electrification, namely that if you use electricity as the energy carrier for your vessel, and you assume that electricity has been produced by a windmill, then you have the lowest losses from the windmill tip to the wake of the vessel by using pure electricity. Converting into hydrogen, ammonia, methanol, or other fuel types include losses, and essentially that would mean to drive the same amount of vessels would need a larger amount of windmills in the world. That's not possible for all situations, but there are some clear benefits of that. And of course, it's certainly emission-free. Second driver, I would say, is the need for flexibility. When we go into the new world of carbon neutral fuels, then a new variation of fuels come out. We've been used to having two fuels, basically heavy fuel and MGO or MGO on our vessels. Now there's coming a wide variety of fuels, and that means that, well, where we're used to being able to have engines in all sizes and all fits for all purposes, then my prediction is that we'll have a more limited selection if we want specific properties of the vessel. And another point is that different types of machinery might convert that fuel into power in efficient ways, in different ways, being that DC, AC. And for all of that, then you need either electric or hybrid systems to orchestrate that this is conducted in an optimal manner. Another important point is that the lifespan of these technologies and the fuels is a little bit unknown. Will we in 25 years still have a specific type of engine as the primary source, or will fuel cells be much more efficient? Will LNG be a fuel that is also used in 20 years from now? Will ammonia or methanol be the dominant electrofuel carrier? Some of these items we can't answer yet, and I think that hybrid systems open for an element of flexibility towards adapting your vessel going forward. If you then look at the technology side, then part of the reason that electrification especially is so limited in you could say in the use as of today is due to price, weight, and risk, and also the size of the battery in itself. And I do see that some of the very interesting developments in battery technology, mostly driven by the automotive sector, will give us some opportunities, whether that's 5 or 10 years from now, to really step change the use of batteries for vessels. There'll also be new power sources that by nature is not rotating machinery, so fuel cells or similar items may come in, and that will call for another architecture of your electrical setup. And lastly, development in electrical systems, for example, DC grids and similar, will definitely also drive a broader application of electrification and also a lower cost of this. And speaking of cost, then that's of course what it comes down to for a ship owner. Is this a viable business? And I think there's the interesting part about electrification, especially, is that it's leaning on a mega trend of electrification in the society as such, and where vessel size applications in the past were kind of an anomaly in the electrical market. Then now, for example, windmill turbines are using generators at the same size of vessels, which means that production sizes, production volumes, and quality suddenly becomes much more attractive to use these for our vessels. We'll also, as mentioned before, see an improving trend on batteries and switchgear and motors on price that will optimize the TCO going forward. And then, as mentioned earlier, fuel prices and also incentives from governments will make it even more attractive to invest in these technologies. So the drivers for this, they are definitely present, but how do we make it successful? How do we make this increased hybridization especially successful for vessels? And there's system integration is one of the topics that I find is most important. It's not the most sexy topic, and it's not what's being presented most in the world as such, but I really find that this is a key enabler for the, you can see, the acceleration of hybrid systems. And I want to share some background of why I think that. Maersk is actually one of the early adopters of advanced systems and system integration, where we already in the 80s on our own shipyard Lindø were experimenting by building some amazing vessels with a very advanced automation systems and integrating some complex systems there. The vessels are beautiful and they work as we intend, but the service on the you can see the automation system has proven to be very difficult because it's a one-off. For many of these, then we experience that the service availability is quite low because only very few specialists know about these systems. And because of you can see the type of integration, then we often need more than one engineer to go on board. Whenever you change something in one system, then it cascades to other parts of the system or to other systems altogether. So our service experience shows that we need to do this right in order to make a good TCO, a good overall cost for the systems. One of the dilemmas that really accentuates this is whether should we plan for midlife upgrade of the equipment, and if equipment is integrated, that means that if you upgrade one piece of the equipment, then it cascades to more, and perhaps the entire system that needs to be upgraded. Or do we want to go for continuous exchange? I'm a big fan of continuous exchange, but that means that you need to formalize your interdependencies between the systems. You need to have structure your architecture and design if you are able to do that. So that's one part of the motivation. The other is that we do want to build efficient new vessels, and we want to reap the benefits of hybrid systems. But this is complex, and many of these systems are novel. And on top of that, we want to go full digital, and we also want to have secure remote operations. That in itself is challenging, but on top of that, some key questions come. How do we get optimal system efficiency of such a system? How do we make sure that our vendors are clear on the demarcations and accountabilities in this? And how do we make sure that it feels like a safe process to integrate these systems, and that we're not essentially facing a premium just for someone to take the accountability for the integration? The answer to all of this lies in good old engineering. I believe that industry-wide engineering practices need to be employed. We need to work with standards to a higher degree than we do today, and we need companies across to work together to make these standards work together on overall. A good example from me is the NMEA bus on navigation equipment that allows all equipment to talk together in a seamless manner. Another item is modularity and interfaces. Of course, standardizing that will be a key part, especially when it comes to maintaining a vessel for 25 years. When you buy a vessel, you can make a system work regardless of the architecture you set up. But after 10 years, then you may sell that vessel to another owner, and he may make some adaptations to the vessels, and suddenly you are with a system that is much more complex and not as it was initially designed. If that's going to be successful, and the maintenance of that system going forward is going to be successful, then we need to have modularity and clear building blocks to work with, so we can service the vessels over the lifetime. The last point, and I think that's one of my favorite topics, is co-simulation. If we are to make the most advanced new systems and really exploit the systems to the edge, then we need to be better at simulating whatever we're doing, and simulating in a way where everyone can bring their best knowledge to the table and simulate how the system is going to work, but without disclosing the IP to each other. Co-simulation in Modelica or the likes will reap that benefit, and I really encourage that we move in this direction. So that's a little bit on the how we're going to do it. And wrapping up on this is that my takeaway is that electrical and hybrid solutions will have an increasing relevance in the future of shipping, especially as we go towards a carbon neutral future. But price and reliability needs to further improve. The drivers are there to get you to make that happen, but it also needs to happen. And then we need to beat the conventional thinking as operators to see these and de-risk the choices of going in this direction. And simulation and standards will help us in that. And lastly, then we need the system integration to provide the transparency and reliability for us to go forward. So that was a fast run through of the thoughts that I wanted to share about how electrification and hybridization fits into a container vessel context. So that's all for me. Henrik, over to you again.
Thank you very much, Morten, for this excellent presentation and also for keeping the time. I think there are a lot of topics which we discuss typically also in our working group 20. So it would be great to have you in there as well. Yeah, now we would like to start the discussion. And you mentioned in your presentation system integration as a very relevant topic. And what I'd like to hear from the others are their view. Why is system integration important in today's context with regard to your work? Marco, may you start?
Yeah, sure. Yeah, hello all together, and to the audience. We can't see you, but hopefully there are a lot of people, and happy to get also a lot of questions from the audience. Yeah, system integration is the systems are going being more complex, and so we need a system integration, and we need standards how we bring these systems together. So Morten also told it. Maybe after 10 years, we need a new battery in a system, and there we need standardized interfaces. And even especially in new technologies, as we have with power electronics, also battery system, they are growing a lot, and we have a lot of technology steps still. So a battery system in 5 years is an old battery system, because you have a lot of efficiencies, costs going down as it is a new technology. And so there we have to find standards, and we have to find ideas how we integrate this in the right way, that we can use it also in 5 years, maybe put a new battery system into, or also in 10 years if we have a new technology, to set it up again. So we need a lot of standards. That's I'm confident that we need this, and we have to work there together, from engine manufacturer as we are from Rolls-Royce, but also for the shipyards and also all the component suppliers. We have to bring this together to a standard that we can work on one way, because we don't have the automotive volumes. So cost bringing down, it's not possible with volumes. We have to do it with standards to make it suitable and affordable for all our clients over the world.
Thank you, Marco. Stefan, may you elaborate a little bit on that?
Yes. Hello, everyone. I'm very happy to be participating on that panel. Yes, system integration is a very important. It is a crucial aspect of a hybrid installation, hybrid energy system, and we, as main engine designer, know it best, as normally our engine is in isolation in terms of control. This is obviously decreasing the efficiency of a system as a whole. So the system, the whole energy system, should be seen as one integrated part and should be controlled as a whole piece. Standards will definitely help. Transparency between the OEMs will definitely help. Sometimes just a simple 4 to 20 milliamp signals solves a lot of problems if we can have it among or between two systems. So yes, and I'm honestly very happy to having heard the discussions this morning, and many of those discussions go in the standardization, modularization direction, which is I believe it must be very welcome from the whole industry.
Thank you, Stefan. Yaya, how do you see this from the perspective of a battery supplier? You are muted.
Sorry. I see it. Thank you very much, and welcome to all those who are listening. I see system integration extremely important, because that is the brain of the whole system, and with the power management system or the energy management system, to collect all data from all equipment and make sure that you at any given time is running this system optimized. So we see that, but I'm not so worried about the standardization, because I think that's already taken place. We have, as the leading battery maker, we have already done integration to more than 35 system integrators around the world, and we do that with our standardized battery management system without any application engineering from case to case. And we also can have different battery technology behind our common BMS. So this kind of standardization is already in place, and even if you need to replace the batteries in 5 or 10 years, we can guarantee you that the interface to the ship will remain the same. we take care of that. And that's a part of our scope to make sure that the different cell technology should not be any worry from the system integrator and the ship owner. So that is more or less taken care of. And we have more than 400 systems now out there, bigger and small. But I think very important that the system integrators, like the big electrical integrators, but we also have experience with smaller system integrators doing a great job, and especially around very advanced power management or energy management system that control the whole system.
Yeah, thank you. Erik Jan, you are working for a typical system integrator. Damen Shipyard does that for decades. So please give your view on that as well.
Yeah, system integration is something really important to us. I've now working for 10 years at Damen, and my first project was a hybrid tugboat. And back then we had quite some challenges with the system integration on it. System integration is still quite abstract term. We cannot really quantify it, so that makes the discussion hard. But in the end, it all turns down to functionality. Everybody nowadays is used to high functionality. When you use your mobile phone, for instance, everything works smooth and as expected. And I think this is a bit the key of system integration. Having the right definitions, defining the right requirements, and later on in the operational phase, making it work. So the vessel or the user experience is according expectations. And this is hard to handle. And what we do now is a lot of virtual testing and hardware in the loop setups to face this challenge.
Yeah, okay, thank you to all. Any further comments from the other panelists to this topic? So Morten, you are when you now order a new vessel and you try to integrate more electrification. Maybe it's not a fully electrified vessel yet. How do you ensure that everything works well?
Well, the traditional approach to that is that we make sure that to review the interfaces from the different makers together with the shipyard, and really make sure that that the dialogue between the system makers is going as planned, and also you can say hypercare through the building process that we see that the intentions of the different systems really is played through. We have a quite strong capability in the technical department to monitor this, but we also need that in terms of getting the systems to operate properly.
Mm-hmm. Okay. By the way, to all people listening to the discussion, it would be great to receive your questions. You can write that in the chat, and the organizers will transfer these questions to all of us so that we can react.
But
pardon?
But I would say for us the biggest problem is when the performance of a combined system.
Oh, sorry.
When the performance of a combined system needs to be validated, who takes responsibility that everything actually works to the high extent? That's very difficult to really get commitment from yards or systems integrators. So that's the other flip side of the coin that I want to mention. Sorry for interrupting.
Oh, sorry, my fault. So okay, so there is still a lot to do, as we heard, and of course, I guess this is not only valid for the very large ships you are more looking in. It's for all vessels, and I think even smaller vessels can be more complicated than a container vessel. Okay, what we are doing in in the Working Group 20 also, which is one important topic, is we are talking here very often about a hybrid system. But what does it mean? We have in the discussions internally, we have seen that this is not a clear definition, and so maybe this is also a topic we can elaborate a little bit on. Marco, how do you see this? How do you define a hybrid system on a ship?
Yeah, for me, a hybrid system is that we have two essential sources or two essential propulsion systems from maybe one battery system and the normal e-motor with liquid fuels. But each of both with a relevant portion. So it's not to put a small battery in and then say it is a hybrid system. So I think there must be a relevant portion, and you have to see a benefit out of this. I think that is the most important for our industry and also for our clients, that we have the advantages we can use, and then also our clients can use. So and we need decarbonization. So Morten told it, there will be legislations and that will be rising, and if we want or if we don't want, we have to do it. We see it in the automotive industry, and it's going faster and faster. If we see Tesla, it's have a value now more than all other automotive OEMs together. Maybe that's too much. That's not the real world, but you see which possibilities are there and what is the pressure. And I think not that much, but it will come also in the marine industry. And we will see there more pure electric in a short way, and we will see, I think maybe in the future, in 10 years, a lot of fuel cell systems, because maybe the battery technology is not possible go with a container ship from Europe to Asia, but with fuel cells, if we get the challenge with storage in for the fuel cell, the storage and the hydrogen, that's the biggest issue. But from a perspective that with a fuel cell going and using it for propulsion, we can do this, and we have to face this in the future. That's, I think, it's the most important thing, and we have to do it, and not just thinking that there is no other way. So we have to change in mind what Morten also said in his presentation. Not the old stuff. There will be a switch.
Mm-hmm. Yeah. How do you see a hybrid system from your perspective?
No, I see also a hybrid system is, without me having an exact definition, but it is a system consisting of two propulsion system, or at least two power sources, combination of diesel mechanical, diesel electrical, or so at least hybrid means that a combination of more than two or more. So without me being not my expertise to make a definition, but we see it as battery plus an engine, or it can also be, we see in the past we call also hybrid if you have a combination of you can go diesel electric or diesel mechanical. So at least more than one per system on board the ship.
Mm-hmm. Okay. Yeah, but this shows already the wide range of how the definition of a hybrid system can be seen. Any other comments to that from the others?
Yeah, I think from today the reason for hybrid system has changed. Previously, we saw that people really would like to reduce fuel costs. 10 years ago, the fuel cost was, of course, a lot higher than today. And today we see that's all about greenhouse gas emissions. If we look to the vessels we have been building, this year we think we have built 40 vessels with batteries. And the most effective use of batteries is when you can recharge. So this you clearly see at ferries, but also at tugs. And you don't have to recharge it fully or do the full profile on electric energy. You can also do it partly. And then the challenge is how to get the battery empty when you are at port. And then you see the efficiency measures. So a vessel on DP using spinning reserve, and then using a battery, then you make big efficiency gains. And finally, you have the vessels with a very diverse operational profile, like an offshore patrol vessel, and then you use hybrid propulsion, the electric engine to sail on low speed, and then the diesel direct driven shaft line for the high speed pursuit. And, I think that's the big classification as we see it from down.
Any more comments?
Yeah, from our side, we also see a hybrid defined as a system where the useful work being for propulsion or auxiliary power, electrical power is done by two different energy sources. We can. It is difficult to define it in terms of functionality for us because we have a set of functionalities applicable for certain ships, and those are not applicable for others. So if I may generalize, the useful work is being done by different sources.
Okay. We received some questions already, and I think there's one which fits in the current discussion. We are talking about system integration, but who do you see as the ultimate system integrator on board a vessel? Also in terms of guaranteeing performance and reliability for the whole system. I think this is a very good question. And I think, Morten, you as the owner of a vessel, you are exactly looking for that. Will you be responsible at the end? Will be the shipyard responsible at the end? So how would you answer the question?
In a traditional setup, then it would be the shipyard that is responsible for delivering a system to us that has the specific requirements, and then it's up to us to make sure that continues to be operated and maintained to keep that you can see that the level. Where we see the challenge usually is that the shipyards, without generalizing, if we have established building blocks, then the shipyard is good at for each vessel to say, hey, this is the way that the setup looks when there's known components. But when it's completely new systems, where the shipyard are not specialists, then it becomes more difficult to find that. And we've not seen it so far, but there's been talks previously about having a specific system integrator role that's supporting the shipyard to get to that and being accountable for it. But for us, we buy a vessel from the shipyard, and they are the ones that are accountable towards us.
Erik Jan, how do you see this?
Yeah, that's definitely also our experience. As a shipyard, we don't always feel technically responsible, but in the end, we are always accountable, and that basically makes us also technically responsible. So that's why we, as Dame, take the full responsibility, especially for smaller vessels. So we see ourselves more as a solution provider, also providing the shore infrastructure if that is needed, because that's a big challenge as well. When you have an electric vessel, also making the shore connection, shore charging station working. I think a good example are the small urban ferries in Copenhagen that we delivered last year.
Okay. Yeah. Marco, if I may come to you, Rolls-Royce Power Systems is a quite big player in the market. Could you think of a role that your company is responsible for the complete system on board a vessel where the hull is built by a shipyard?
Yes, and that's the way we are working on, and that is our strategy, because we think that is the key solution, and also our customers are forcing this. They want one system a responsible supplier. So I think only selling motors or combustion engines, as we are doing today, and it's a good business, and we are earning a lot of money with this. But it will not, in the future, we will not be successful with this. So our roadmap is also 2030 roadmap is that we are going to a system provider or even solution provider. So what need our clients, like what need Damen, what need Maersk, and then offer the whole solution. Not maybe doing everything by our own. So we will not produce cells by our own. We will buy battery systems, and not doing everything by our own, but put this together in an intelligent way that it is working, and that also the question was guaranteeing performance and reliability in a complex system. That will be a challenge, because it's easier to handle only a combustion engine than a combustion engine with electric motor, with power electronics, with switch gears, with a battery system, and so on, and then up to the bridge of the vessel. So we see clients are forcing this, and we are going to be a solution provider, also with maybe guarantees. Finally, we did this on the rail systems, and we will do this in the future also in marine systems for the lifetime of a ship.
Okay. Yeah. Stefan, the business model of WinGD is different from Rolls-Royce. So is this also thinkable for you to act like a system integrator together with your mother company, or will you keep more in the background and just deliver engines?
Right. We have a rather flexible business model here, and there is a part of it which also we also act as a system integrator. We have partnerships with several companies for electromechanical components, battery packs. So generally, we're component agnostic. We listen very carefully what the customer wants. We analyze the requirements, we collect them, analyze them, and have a suggestion of what the topology would be, what the components surrounding the main engine. Obviously, we put the main engine in the middle as being the most efficient energy producer on board, and on the same time, it is the heaviest fuel consumer. So one has to be careful. Yeah, we are open to work with any component suppliers, provided that set of our requirements and interfaces are fulfilled, so that we can run our energy management system on the system that is being integrated. I would say that the ultimate responsible for the performance should be the party that is providing the energy management system, because if the control strategies are suboptimal, obviously the performance would not be met. But it is not as easy and as straightforward as just said. It all depends on the components as well. So it is rather a thin line, in our opinion, the optimal sizing of the components. So what we aim for is not oversizing and not undersizing them, because each of those aspects has its risks. Most predominantly, if they're oversized, the benefits are becoming marginal, and return on investment is lower. On the other side, if undersized, we run into safety issues. It was mentioned earlier about the virtualization of the system. This is something we also put a lot of emphasis on, and we have this was the first step of starting hybridization activities within WinGD, and we believe that this can mitigate a lot of risks and will help us deal with uncertainties on a very early stage, especially as we have our transient capable models in that for the main engine. So it is a crucial part of the whole process.
Okay. Could you think that your company takes also over full responsibility for such a complete system integration, or would you act then in as part of a consortium?
Definitely, we will never ever take responsibility as the integrator. That is a very clear strategy from us, because we work very closely with all the integrators, as we see that the Wärtsilä, the ABB, the V-Ship, or smaller one like Vard Electro or Westcon or Norwegian Electric System. These are our true partners and clients. We will never ever step into there, but we will have working very closely with them when we develop the battery management system. So our system can talk seamlessly with their system, and how we can develop together also the best service offerings, and how we can share data, and how we are on the same digital platform. But definitely no, we will never step into the system integrator road.
Mm-hmm. Yeah, there was just a question coming in. Thank you for that, which fits very good to this discussion. Responsibility for performance and reliability will become increasingly challenging when hardware and software from different suppliers needs to interact in a hybrid system. Do you see this as a barrier or as an opportunity for industry partnerships? Morten, what do you think about?
That was a long question. I'll just digest this.
Maybe I can say something.
Yes,
okay.
Thank you.
Yeah, of course.
For me, it's an opportunity, and it's not a risk.
Okay. So
okay,
you
I
see
go
this as
Morten, or you want to go?
Yeah, I think
as an opportunity, yes, and we have to see that as an opportunity, and we cannot do everything by our own. None of our companies here.
I agree. The challenge becomes how to do it, because when we see that as long as you look at your individual system and only guarantees that, then you can see you're not necessarily responsible for the interaction, and you see how it fits into the greater whole. So I think you either you need to be very crisp, and that's where the standards come in to really define what those accountabilities and the reliabilities are, and what the performance needs to be of that system. That would be the number one. Or you need to really work together to not just look at your own barrier, but also look broader into the system you're developing together with their partners.
Mm-hmm. Any other comments from the others?
No, I think that you will see industry partnership, and we are working very closely. As I said, we have done this with more than 35 system integrators already, and we are constantly talking about what should be the best interface, but also how should we share the risk on. Typical for battery is the battery sizing and the lifetime calculation and these things. So I think we will see different business models and different way of risk sharing going forward, because we have a problem now that of course when we as a batteries company selling into an integrator, they need to take a risk on us. They sell to a shipyard need to take the total risk, and it's not sustainable, and it will be too expensive. I think you will break up some of these things, and you will see some partnership and some different way of contracting also where you place the performance and the risk where it belongs in the shipbuilding contract. So there could be contracts directly from the ship owner down to, for example, us, if this is related to the performance of that equipment. And today with big data, we can have different business models there.
Perhaps just adding a flavor from my end, when you look at the life cycle perspective of the vessel, the differentiation, the components are usually easier to exchange. But will the components then fit into the new interface? You addressed that earlier, Geir. But the other problem is, can the software actually run on those components going forward? If it's Windows-based, will that be serviced in the future? So you see, you add another layer of complexity by having a software from a different vendor that needs to stay compatible with whatever platform it's running on.
We see that as a demand when we do all our R&D going forward. We need to take responsibility for that, both because that we look after our own service offering, but we think this is on our responsibility to make sure that you can upgrade and you can move on and be competitive. Or otherwise, we need to engineer this kind of solution that we don't bring that cost and risk to the ship owner. We need to take that responsibility as a true partner and the right equipment supplier for that solution.
Yeah, when it comes to these interfaces and so on, Erik Jan, when you engineer a new vessel and you are you are starting with the integrations. Of course, you are defining the different components, but are you also defining the way these components talk to each other?
So coming back to the question of the responsibility of performance and reliability,
and the interfaces.
Yeah, I don't think that's a barrier. Clients demand these kind of systems, so we just have to enable it and provide it in a good way. About interfaces, what we usually start is first selecting the right propulsion configuration for the ship. That's really where the integration starts from our point of view. This starts with a good ship design, good propulsion selection, and then you look inside the ship how you can make it most optimal, which is a kind of trade-off between costs and cost savings, so CapEx and OpEx. Then the interface is something we don't really define. It's more something we coordinate. So we make sure that there is communication between all the suppliers. If they have a preference for a certain communication protocol, then that's up to them if they all agree on it. What we do is we make a kind of test scenario at the end. So when all the systems are ready, we are performing a hardware in the loop test for the most complicated systems, like hybrid systems. And then we have all the experts together in a room. We connect the controls and we interface it with a virtual ship. And this virtual ship then represents the actual ship. And in this way, we can get the functionality out of the system as we would have it on the ship itself. And this really enables and fast forwards the whole commissioning of the system and makes it much more reliable once you put it on board. And it reduces also the commissioning time. This is how we try to take the ownership and coordinate the development of these novel systems. New development is really modularity and going for more standardized solutions. And trying to use those across our product portfolio, what we offer as Damen.
Yeah, I think modularity is a good keyword. Could you think that we have different vessel types, vessel sizes? I think it would be also helpful if there can be a kind of standardized modules to be used in different applications. Is this thinkable from your side?
Yeah, definitely. We see vessels with different types but same power ranges. So the vessels we build are usually propelled by high-speed diesel engines. So they already have a kind of upper limit. So with a high voltage DC system and a few sizes of switchboards, so to say, or electrical drives. So the electrical converter with the electric motor, you can make already quite some ships, making use of the same core platform, so to say. And then you can combine and later add on fuel cells or whatever the customer wants. And that's what we see. So we did now a lot of projects, all one-offs, a lot of developing time inside the projects. When you switch from supplier A to supplier B, you see different challenges, mistakes, we should call it maybe. And that's what we try to reduce by going more for more modular solutions. Using the system engineering approach to set it up.
Marco, how's your view on that? Are you can you provide such, let me call it, power packs, however they look like, to system integrators and shipyards?
I don't know if I got the question right, because I think I have some problems with the internet, or
shall I repeat it?
Question.
Okay.
Yeah, that would be great.
Marco, no problem. Erik Jan just told us that modularity is very important, and that you can use these modules also for different ship types if they are in a similar power range, or you can use more modules in this respect. Is this also a strategy of Rolls-Royce to provide a kind of standardized power packs? Power packs is maybe not the right word for, but to use this standardized solutions modules?
Yes, I think, yes, we are working on this. At the moment, it's hard because, as also Jan Erik said, it's a lot of one-offs. So we don't have a lot of the same ships we are working on, but we need this in the future also to going to cost down, and also the complexity to reduce it, and to have it to can handle this complexity. We cannot do at the time a new battery system, a new electric motor, a new converter. We need their building blocks, as we heard also already today, to better integrate it, to handle the complexity, and also to reduce costs.
Okay.
Lead time is also an important factor for us. So having a shorter building time.
Yes.
Yeah. Okay. We started with the large container vessels of Morton. But when I would ask you about the best suitable vessel types for electrified powertrains from today's perspective, what would you name as top 5 for that? Are these more smaller vessels? Are these specific applications? So what's your thinking on that?
Well, I don't know if I should have a go at that first.
Yeah.
I think the answer to all this with ship types is it depends. Offhand, some of the hybrid solutions would fit best with something like offshore vessels and work vessels that has intermittent load, that has thrust operations throughout. The hybrid solutions work super well with that. However, fully electric doesn't work because we don't know how long term they will be at sea. So they would need, you can say, a longer guaranteed operation that at least today's power packs will provide. If you go fully electric, then there's no doubt that the range of the vessel, range and power consumption, that's the dimension criteria right now. So tugs are perhaps on the borderline, but otherwise, whatever there's shuttling back and forth is appropriate. Barges also as well, with low speed and short ranges. But perhaps the more interesting part for us is that the very large vessels, they have a different opportunity because the investment is so much bigger and the fuel consumption is so much larger. Then it also allows for more, you can say, investment in technology and investment in system engineering for each vessel type, where 1% savings represent a larger sum of money than it does for some of the smaller vessels. And I do see that there's, especially with future fuels, perhaps being at $1,000 per ton, that will allow for a lot of good investments in efficient systems, and looking at how do you also for your auxiliaries get the optimal power production cost, and not just for the propulsion. So that was a few reflections from mine. It wasn't really 5, but I hope that 3 covered the demand.
Maybe I can comment on this because we have been involved in most of these ship types. Of course, fully electric one, we see, as Morten said, we see typical double-ended ferries that can charge in each end of the route, and we have seen, many of those being built, mainly, of course, in Scandinavia, but we also see this coming around the world. And then, of course, offshore supply vessels, typically when you are in DP operation, where the battery can act as spinning reserve and in peak shaving. And then you see, of course, other areas in as a hybrid where you have variable load, where typically battery can act as the peak shaving, but also as a spinning reserve. And then, of course, if you have some operation where you can generate back some of the power from a crane operation or other one, that also is helping a lot. But we also have seen now that you have fully electric tugboat, for example, because the battery technology is coming, and we see also the endurance will come now, because first of all the size of the battery, how much you have a lower weight, but you can also get the lower cost. And in some area we're working also that you can get the volume of this down. So we will see an increase of those things. But if you take the 5, I think you are on ferries, you are on offshore supply boats, you are on some of the drilling rigs on DP, and you are on tugboats. But we see also on general cargo ships, if you can then, for example, reduce the number of auxiliary engines, and you can optimize them combined with the shaft generator. So also we see as a cargo vessel with of course, if a big boat rests on other auxiliary equipment, the better the calculations are.
Okay. Stefan, you are coming from the really huge engines, the combustion engines. But how do you see this regarding vessel type?
Right, I actually see it quite positive on the big container vessels. We have run a study for 13,000 TEU with 38 megawatt engine at 80 RPMs. So we can rationalize the installed auxiliary power, and on average, and propeller fouling actually requiring more power. So we have about 3 to 6% fuel consumption. And as Morten correctly said, in terms of money, this is an impressive number. So we, as far as I can remember, we achieved that with 4.5 megawatts shaft generator and 1 megawatt hours battery. So the return on investment conservative case is just over 3 years. Right, so I see it very promising as long as the energy management is done right, as long as the peaks are shaved when they have to be shaved, and because there is quite a fair risk that some efficiency is lost in conversion, more than what we would like to have. Yeah, container ships, our calculations and simulations show that this is definitely a segment that one should look into. Another ones that we see also very promising are car carriers. We also have we see also demand, and we see also on the market quite many of those ships being hybridized for the recent years. Shuttle tankers, offshore vessels, obviously. Also, we see potential in a smaller container ships, feeder containers. And also we have looked at a few product carriers, relatively small product carriers, that also the business case is quite attractive.
Okay, yeah. When we there is a question also for smaller boats. So what is the correct electrification solution for propulsion purpose for boats less than 24 meters length? So, Marco, you have a lot of experience also from the automotive industry. Could you think of a solution where we have a pure electric drive and, for example, use a combustion engine or maybe later a fuel cell as a range extender for that?
Range extender, it didn't work with the automotive industry, and I'm not sure if it is working also for the marine industry, because if you're putting more systems together, it will be much more complex, and the costs are also going up. So I think it's as Morten said, it depends always on what you need and what are the requirements. I see pure electric, for example, for ferries. If you have maybe half an hour or an hour ride from one place to the other, and then have the possibility to charge the batteries when the people are going out and in. That could be a possibility for pure electric, also with a battery system. And then the fuel cell gives you the additional point to going longer ways. And we see fuel cell. I think that could be, especially in the industry like marine, an option. I don't see it in the automotive at the moment. I think their battery systems are strong enough, and the costs come in the right way, and also from the range, so that automotive don't need cells. So we need to push not out of the automotive industry, we need it out of the industry. But I see fuel cells, and I see also pure electric, but it depends on the range and how long have the ship have to go. And on really small boats, there could be both possible. Normally, if you're going less than 24 meters, then it will be hard also to put the battery or the amount of battery in to go only pure electric. And you don't have so much the recuperation in the water. That is not possible. So as we heard, a load shift. So then it is interesting, and then you can save a lot of fuel, and then it could be an option as well.
Mm-hmm. Mm-hmm. Yeah, I don't think size is really a good criteria. It really depends on the application. We build a lot of high-speed vessels, and then you want to be fast, so then weight is crucial. If you have a tug, for example, which is slow and has a lot of displacement, then you have much more options to electrify. This is one of the reasons that we are now in constructing hybrid urban ferries, high-speed urban ferries, the water bus for Rotterdam. These are hybrid at first, and later on will be fully electrified. This has to do with the energy density of batteries and the short charge stations which are required to make it full electric. So we do not do that at once.
But we are involved, of course, in many of these projects, and we are looking at projects where do go fully electric on high-speed vessel to quite a distance, because we have today 7 different battery types, and of course the battery type we have now that is suitable for electric, that is less than half weight of what is the battery that we put on the tug and the ferry. But we see also in some of these cases that we need to optimize also on volume. So you can get enough, one thing is the weight, but also that you maximize the volume in the hull to make sure that you don't have to grow the vessel just to carry the battery. So I think you will see shortly some quite innovative, also high-speed passenger vessel that goes quite far with quite high speed, full electric. And as you discussed, the question was, we also see some of this that you might have a fuel cell as a range extender, that you can do partly some of this backfilling of energy while sailing.
Okay.
Yeah, I think that we see more in the future, that batteries will stay developing, and that also the application will increase, and the applications types of vessels.
I think, Jan, what you mentioned is bringing us also to an interesting question, which came up as well. do you see possibilities to retrofit existing vessels to new electrical solutions? Maybe not a container vessel from a large two-stroke engine today to a fuel cell, but maybe smaller vessels. Is this also a business case?
Yeah, I'm personally more in new building, not so much in retrofitting, so that's hard to answer.
I can answer this. I think not 50, but I think we're close to 50%, maybe 40% of the vessels installation we are being involved are retrofitting. Especially if you already have a diesel-electric propulsion system. I think if you have a hardcore old the direct drive mechanical system, I think you are more in, that takes too much to do. But on system that already are electrical, or at least or have a shaft generator, you can easily fit this. And you look at, if you look at the offshore supply vessel, due to the market have been very weak, I think there is very few new builds with battery, and it's a handful that we are involved. Otherwise, all of them are retrofit.
That we see as well, that now customers often choose for diesel electric, but they do it because they see battery opportunities for the future. At this moment, they still go for the diesel engine, but they prepare it for battery installation later on.
Morten, are you planning also to do retrofitting on your vessels regarding our topic?
I see the electrification topic has many aspects for us. AMP, shore power, is one item that will come in. I think for all our upcoming vessels, considerations of how batteries in the future or now will optimize the power plant is considered. How fuel cells in the future will optimize is definitely some of the considerations. But for me, this flexible power plant is the key word. To see how do we ensure that you remain open to these opportunities of the future that we know will be coming within the next decade. So how do we avoid making archaic ships and are ready to step into that? And sometimes that's very small modifications. It could be as little as making sure that your switchboard can be extended. But we see in the current fleet, some vessels have not had that preparation thought into it, and that makes it super hard to reap these benefits going forward. But on that note, there's not much difference between adding an AMP, adding a battery, adding fuel cells. It's a matter of how you can see space and opportunity to integrate it into the existing system. That is kind of the heart of the problem. And then you can plan more details, the more sure you are of which technology you want to head for.
So this means there will be two different, let me call it, business models. One is, like Erik Jan mentioned, that the new build of such electrified vessels. The other one could be also business on retrofitting existing vessels, also with standardized solutions. I think this is quite important. And also we received several questions regarding standardization. So my question to you all is now, what are currently the biggest hurdles for today for this implementation? Do we need, or we have already heard that we need more standardization, but what can be done, what we have to do to overcome that, on one hand from the technical side, but on the other hand also from the regulatory and the classification societies?
Yeah, what I see from the Damen side, from technical side, is of course you need numbers. We are very familiar about standardization. That's in our DNA almost. But it starts with numbers, because standardization first costs money, and later on you with the numbers of vessel you are selling, you earn it back. And I think that's now emerging. almost every vessel has some kind of hybrid aspect on it. And yeah, now's the time to consolidate a bit the hybrid aspects. From regulation point of view, I don't think there are big hurdles. But
okay, so there you see currently no action required, not much at least.
No, as far as I know, we don't see any issues over there. But that's maybe typical for our ship types. So we are not in the big merchant vessels. The others in the panel. So for smaller vessels, I haven't heard that there are certain regulations blocking this.
What I see from the component side is, or especially battery. We have some safety standards, and we have to assure that we have one safety standard and one standard or the same requirements in the different certifications for the battery systems, because I think from the cost perspective, it's not possible that I have to, if I going for Lloyd or DNVGL, that I have to fulfill different tests. So because safety is not a thing, safety must be guaranteed, and there should no differentiation for nobody of us. So it must be safe, that's for sure. And we need their common standard, or at least not different standards. Let it take like this. I think there are not a lot of standards that are different, but not everybody had done his standardization on this or his definition certification. So that's important from the industry view. From my side, maybe Gaia can add something, because doing the same test for the same battery system, that will help a lot, because we don't have the big volumes, and if we have for each 100 batteries, we have to do an additional test that bring the cost where we don't need it, because cost must go down to get a right volume out of it and bring it to an effective way, not only to legislation, but it is also much more total cost of ownership benefit.
Yeah, we have sold that we have put our own safety standards and tests on a higher level than the classification society. So we have done all the tests, and therefore we have standardized. But we as the leader, we set the standard and move that higher, and therefore our test is acceptable if you have Lloyd's, or if it's DNV, or it's JG in Japan, or it's RENA. So we set that higher, and I think that any system integrator or ship owner doesn't have to worry that our batteries come without those kind of tests and with an approval. So it's not any issue for any system integrator to worry about and to do this. This is on us as equipment makers' responsibility, and we take care of that. And we have our own standards that is higher than class. And we are working closely with the class, but also likely important area is the flag state. So if we have been working with NMA in Norway, or we are doing this with the flag in Denmark or Sweden, or as I say, Japan, or whatever, Transport Canada, US Coast Guard, all this is taken care of from us as a battery maker. So you say who is doing the integration doesn't have to worry about that.
Stefan, Morten, any hurdles?
No. Do you want to go first, Stefan?
Oh, sure. From the classification perspective, we also don't see any hurdle. What we would like to see is more standardization, and Morten earlier mentioned about co-simulation. And so what we're struggling with is, despite from our main engine and some generic models on the other components, so we would really appreciate more collaborative approach between the OEMs, that one can virtualize the system and really minimize the risk at the later stage when everything is on the shipyard and when we have, for example, mooring trial. So.
Okay. Morten?
I think you're touching upon one of the most important topics, because when we've been discussing that hybridized system with class, If it's new systems, then you approve it and you make a risk assessment of the specific setup and see if that matches the basic requirements for the vessels. And often that's not the problem. The problem will come later. Then will the system then actually act according to this to the requirements we have? And simulation is a big part of that. That if you could validate that at an early stage, that makes things very very attractive. The second part is, and that's perhaps not as much class, but will it then be feasible to operate in real life, where you can see the classrooms as one place, but usually our requirement for the vessels is higher than the class, and there you are kind of we need these engineering tools to help us there, because that's not class rules; it's more class as a partner to develop the vessel that we needing.
Okay. Yeah. Okay.
We are also a strong supporter of co-simulation, to partner up in simulations. That's also why we joined the open simulation platform created by DNV, hosted by DNV. Corvus was also a partner in that project, and that enables to at a regulated way that you can set up a simulation model together. And that is then regulated by DNV. So the IP of the models is all taken care of. So you cannot misabuse any models or use it for other projects than agreed upon. So I think that's for everybody nice to check out the open simulation platform.
I think as I recall, the OpenSim is based on the same as the Modelica framework as the automobile industry in Germany has also been used for decades. And whether it would be OpenSim or another facilitator or that, then you can see that direction where everyone can bring their models without disclosing the details in it and co-simulate this is a really good idea.
Yeah. This is also the task of the subgroup tools in our working group. So this is very important, a very important topic. There are two questions which are maybe specific for you. One question is there a pure electric solution for working boats, for very small working boats, less than 10 meters? Is there a pure electric battery drive reasonable?
We don't have a clue. We don't address that market at all, and I don't know. I think there are Tokaido and some brand who can do some of these things based on BMW i3 battery. There is some initiatives in Norway for Evoy with also electric outboard engines. Tokaido, but so far what I have looked into this, not as part of my job in Corvus, but maybe for private purposes, they are still quite expensive compared to a Yamaha or Mercury outboard engine. But I cannot answer on for this at all. The next one regarding boats over 50 meters would be a reasonable range for a full electric. That is almost asking how long is a sausage, because what is the speed and power requirement? We see that we see today that we can easily 3, 4, 5. I mean, it's very difficult to answer only on the length or the size of the boat.
This is very difficult to answer. This is fully clear, but maybe we can stretch this a little bit to the utmost. Do you see a possibility to operate a container vessel between Europe and Asia purely on battery?
No, we have done some calculation on that. First of all, you will take most of the container capacity on to carry batteries, and we have to remember, battery is maybe the most expensive fuel tank you can think about. So that maybe you can make it to fit in an Excel sheet, but now you cannot do that. That as not as we see. So that will not happen. But keeping in mind, we have some crazy inquiries once in a while that people want to make a ship that can go around the world full electric and things like that. But I don't see that in the near future.
So I think it makes more sense to put the electrical energy in alternative fuels and to use this fuels on board, independent if it's an internal combustion engine or a fuel cell or what else for energy conversion. Stefan, in this respect, are you also working on engine concepts to burn hydrogen or ammonia and so on in your engines, which can be produced by renewable energies?
Sure, yes. We as WinGD, we are working, yes, on alternative fuels. Yeah. I'm not sure if I'm the right person to talk about that now, given that this is not my expertise, but I can say, yes, we do. Please reach out if you need more information about it. I will make sure that, you get the answers.
Okay. Marco, from Rolls-Royce side, I think you are working in the same manner?
Yeah, we see power to X. That's we don't know what it is maybe in the future, but we have a look on each of this, and also the H2 motor. If we can get this, that would be great for everything in the round. But I think there is still a way to go. There are a lot of research, and we for sure also looking on this. What we did also for our strategy is we set up a unit that is called Power Lab. So how as from power and laboratory, and they are looking on power to X. They are looking on fuel cell systems. We did a cooperation or we have a cooperation with Daimler also on fuel cells, and to use this once and bring it into our industries. And there, the marine industry is one of them. Also, our power generation, but also the marine industry. We have a look on this, and we see this first projects, I think, already launched, and we see there a big opportunity in the future that fuel cells and also the H2 motor maybe will come up there. Because we heard from Gaia, battery is not the solution to go green from one continent to the other, so we need another option.
Yeah. So and my personal opinion is also that the combustion engine is not dead, and also not in the next 20, 30 years. Yeah, please.
Yeah, that's right. That's different than in the automotive industry, because in the automotive industry, I think 2050 we don't see new cars with combustion engines. Maybe earlier, but I think in the marine industry that's a longer way, even if it comes to them. So diesel will be really relevant, also gas and power to X fuels in the future. But it will switch to more electrification.
Yeah, it will be the combination. Yeah, Erik Jan.
Yeah, as Damen, we have lately announced our new company ambition, which is becoming the most sustainable and connected shipyard in the world. And the sustainable part, from product perspective, is really going towards electrification and future fuels, alternative fuels. So that's a quite actual topic within our company. We've looked into it, and we think if you can go for electric, then go electric, because it's the most efficient way of powering your vessel. But as a next solution, we see methanol as a very good marine fuel, especially for our typical ships, which are complex vessels, medium-sized, small. So we talked a lot about fuel cells, but I think the fuel cell is not really an issue. It's more the hydrogen to put that on the ship. That's quite challenging. So therefore, we would prefer methanol with a combustion engine, actually.
I think I support that comment from Erik Jan a lot, that it's not an issue to make the technical solution on the ship, but we have it will take some time before the infrastructure and the bunkering facilities and availability of alternative fuels are there. And we saw that from the pioneering on LNG as a fuel that take many years to get that up to a certain scale. And you see that just recently you start bunkering and you have big container ship running on LNG. From the earliest pilot with the ferry here in Norway, 2001, and so on, say 20 years ago. So that also will be a challenge, even if have a big drive for alternative fuel also on land. It will take some time.
Yeah, and we need forerunners with technology. Let me call it pilots that demonstrate that it's working.
Yeah.
Okay.
There are many ongoing at the moment, pilots.
Yeah. Yep. Pardon?
I was just saying that I think the big challenge right now is that there's too many options, and even if we spend all the R&D resources in the world, then we cannot pursue both electrical hydrogen, methanol, and ammonia at the same time. It would really benefit the acceleration of this if we are zooming in on fewer fuels to develop, because that will, in the end, if we have a diesel generator that can run on methanol and a main engine running on ammonia, then that's not a vessel that we can use. So we need some synchronization between the different makers to rely on a few fuels. We like methanol, we like ammonia from our side, so we're hoping to converge the industry in that direction.
So you are the owner, you can set the pace.
Yes. We're trying to do that as much as we can.
But this is a good lead to our last part of the discussion, the outlook 2030. So 2030, 10 years or 9 years ago, sounds quite long ago, but from we just heard that the development of the LNG propulsion takes 20 years up to now. So 10 years is not very long. So what is your expectation your company is doing 2030? Morten, would you like to start?
Yes, I think by 2030, Maersk has launched a few years back an ambition that the first fully carbon neutral vessel would be operating before 2030. And I think with the way the world is shifting, we might even be faster than that. So I think, yes, at that time we will see a carbon neutral vessel, but that will be operating on whether that will be a methanol or an ammonia to be seen, but one of these two we believe in. How that then relates to hybrid systems? Well, essentially, you can build a vessel that's carbon neutral without having hybrid systems on board. But I think in terms of efficiency, we would definitely look into how we can make that setup as good as possible, because the efficiency of the engines that will and the entire setup will definitely affect the commercial viability of such a vessel.
Erik Jan?
Yeah, so we will continue with the electrification. So the product will be more electrified. I think that's ongoing and won't stop. And this goes more into modularization, so modular systems, and also digital, so connected and maybe remote controlled. So really the smart ships. Making it more sustainable. When it cannot be electric, it will go for an alternative fuels. We expect now methanol as the most promising candidate for our ships. There's also a big supply chain discussion, of course, ongoing, how to make it affordable as well. Nevertheless, it's liquid, so I think the distribution and bunkering is way easier than for LNG. So this could also mean that it could go faster.
Okay.
Yeah.
Stefan?
Our product generally can burn any fuel, so this is a good part of being a two-stroke engine designer. So we are getting credit to be able to burn what would be defined as a fuel in the future, or the next bridging fuel after the LNG. I personally see that the degree of electrification will be increasing. Batteries on board and supercapacitors and so can have a lot of positive effects. So the efficiency can definitely be boosted. Yeah, as WinGD, we look, we are getting ready for the next fuel, regardless of what fuel that would be. And on the electrification side, we are also looking that in parallel and seeing how we can have as efficient as possible integrated system. Yeah. So we are reaching beyond being main engine designer. We are going into being energy system designer, provider, solution provider.
Mm-hmm. Marco?
Yes, as both said, it will be a shift, and the shift will be reasonable. Even we did different cases, and also on like CO2 and legislation, what could come up, and depending on this, the percentage of fuel cells, full electric, or the power to X will increase more or less. But I think at least we see at the moment we don't have maybe you have 1 or 2 systems out in the market from last year. So, but we see a really big increase, maybe 20%, 30%, and depending on the case, maybe we see already 50% of our revenue from new technologies, say it like this. And today we have more or less 100% diesel and gas, and that's a big shift. That don't see that we lose a lot of diesel or gas, but we will add, and the grow will come from the new technologies. That's for sure.
Mm-hmm. Mm-hmm. I'd like to add 2 more points to you. Not only just a simple outlook. The question is, will we see 2030 also other battery materials like lithium? And how about the use of supercapacitors?
Then of course, what for the 2030 outlook, we will have widened the range of battery, that we have more optimized solution for that specific vessel. Today we have a family of 7 different batteries for different requirements from weight and volume and sea rates, and we have lithium iron, and we have lithium phosphate. Yes, there's a lot of development going into batteries now, and especially driven us from the automotive. So I think we will see solid state, and I mean without electrolyte, which can of course do something with the safety, do something with charging capacity, and these things. But that will be driven by automotive, and we as a battery system provider, we don't make the battery itself. We just buy in and look for the right technology. And I'm maybe not the best man also in our company to do technology scouting. We have better people than me looking into that. So I don't know. And therefore also, frankly speaking, I'm not the right person to look at supercapacitors. We have one battery today that is in between a supercapacitor and a battery, but they that have a very limited storage capacity. That is a battery that can take in and out huge power. It typically has, if you have a heat compensation or a drilling tower, but cannot store. So unfortunately, I am not the right person to talk too much about the comparison of supercapacitor, neither also on what's happening in the battery cell space, except that our company is now 12 years and we are already on the 3rd generation batteries. This speed of innovation will rapidly increase as well. So I can only guarantee that the batteries are better, lighter, more capacity, and I can guarantee that we will take care of the interface. So we will be able to replace those batteries in the existing vessel without any headache for owner and system integrator. And more than that, I cannot say about the future because I simply don't know. But we have to be very flexible and adopt the technology that is available and mainly driven from the automotive industry.
Yeah. Thank you.
I have one challenging question. So it's driven by automotive when we see the automotive crisis within the marine industry. Or what we can expect, because at the moment we are struggling with costs for hybridization. So that is one aspect at the moment, and we get this with volume for sure, but we also get this from we have to reduce the cost. It's not only the battery, but it's also the DC switch, the gears, the motors, but especially battery costs are still 5 times automotive prices today. So what do you see there in the future, and what we have to do also from our side as system integrators and from shipyards? What will help you to reduce cost, because you can use the same cells?
No, but then I don't know who you talk to when you talk to the price and 5 times. But maybe your sales guy should go to talk to you if you're getting so high prices. That I don't know. But I can tell a story. If you look at Ampere, the mother of all battery ferries, she was launched 2016, and that time there was the price of this the battery around $1,200 to $1,400 per kilowatt hour. Then the next generation that we come with now in 2016, then the prices were down to below 500. Maybe now you see things that it is falling below 500. So I think if you look at the cost curve, of course you're using the same. We don't use exactly the same cells either as automotive, but we need to pack them differently, and of course we need to utilize the cost down curve on battery cells, and then we need to look at standardization and automated production. We have invested in fully robotic factory to drive down the cost. If you look at the battery modules that was back in 2016-17, they was almost handcrafted and was handmade. So this is coming down, but there will always be a kind of premium on top from automotive, because we have a totally different safety regime and how we design the batteries for marine than you do in a car.
Yeah. You just talked about production. How about scrapping batteries?
That also is interesting, because they have a lot of valuable metals. So you see now Northvolt, the big Swedish new cell manufacturer, and Norsk Hydro, one of our major shareholders, has invested in a JV in Norway, where they're also going to look at a fully robotic automatic recycling facility of battery and bring those metals and minerals back to the supply chain and have a closed loop. So there will be a lot of this solution developed, and we are looking today also very much on what do we use those batteries for in second life. Can there be a second use? And of course, to ensure this, we are collecting data on each cell level up in the cloud and always simulating the life calculation, and see if then also how can we use those battery in the next life.
I think recycling is an important aspect. I think, Morten, this is also something you have to deal with as the owner of such devices at the end.
But I think what Gia is alluding to, and I actually think the same, is that it is possible to recycle and reuse these batteries. And I've been looking at both this second life, where things that have been used in an automobile, but because the end of life is there coming, perhaps that can be used in a maritime industry for a different purpose. Who knows? So I actually think that the outlook for recycling batteries is much better than, for example, windmills. That has been one of the challenging areas in Denmark, for example. So I think I'm not worried about it, but of course it's an industry that needs to be developed and that needs to have the volumes to automate factories, like you mentioned, Geir. But certainly we have a very high responsibility towards the scrapping of our vessels, and take that quite seriously. So
And therefore we take that very seriously, and we have documented from Class that we have more than 99% recyclability of the batteries, and we're looking also how can we into our supply chain today use already recycled aluminium, plastic, other things, because sustainability is extremely important. We work very closely also with the cell manufacturer how to optimize that, but a lot of these things also to make the battery cell production more sustainable is driven today by the automotive guys.
Okay. So we are close to finish. I think we have 10 minutes left. Are there direct questions from the audience to one of the panelists? There was one coming in recently. What are the costs needed to be included in the system to support a battery in dollar per kilowatt hour? So I think this relates to the need. I think Morten, you mentioned once it would be great to have a battery for $100 per kilowatt hour.
Yes.
Yaya told that currently it's 500, so there's a little bit of this discrepancy between.
But I think what Brent here is alluding to is that the battery is one part of the cost, but the system integration, the switchgear, etc., and the drives is another part of the cost. I think first of all, we have to separate that the cost of that integration is not for the energy, that's for the power that's delivered by the battery. So larger batteries doesn't necessarily mean higher integration cost, but the power output is what drives that cost. I think an old rule of thumb for conventionally sized batteries is that the cost of the battery is equivalent to the cost of the system integration. But of course, with declining battery prices, I think that's declining faster than the drives prices. So I think it's a matter of analyzing the specific need. What I think is most interesting here is that if you develop a vessel that is anyway having a DC grid in an appropriate range, then all that additional cost comes at a quite low cost because the drives are not needed. The drives are anyway there. So it's also about how you architect your vessel to see if that cost is actually included in what you're anyway bringing on board the vessel.
And we also see that the kilowatt hour price also is maybe not the right way to always question it, because we see that, as you say, that in some battery types the kilowatt hour price is low. If you're talking about the very high C rates, it will be a strange way of measuring price only in kilowatt hour prices.
Yeah. Okay. Fine. Any more comments to that? If not, I think there is another question which came in. Is there a future in a diesel and hydrogen mix, and can hydrogen be produced cheaply enough? Is this a question of scale? I think this is difficult to answer here. As we discussed already, hydrogen, the storage of hydrogen on board is for sure an issue. I think Klaas will not so much be happy about that. The question is what we mentioned already: how to burn these fuels. Will it be really pure hydrogen, which we will burn in the engines or in the fuel cell, or will we use methanol or ammonia, which might be more suitable?
Yeah, so I think the storage of the new fuels is again a typical shipbuilding question. It's all low flash point fuels, so you need additional safety measures to prove to class that everything is safe.
Mm-hmm.
So this system integration is more, for the naval architects
Mm-hmm.
to ensure sufficient ventilation and stuff like that. The production of hydrogen, if you look on very long term, I think the projections are quite in favor.
Yeah.
Solar energy prices are dropping. I think the biggest cost now for hydrogen production is the cost of electrolysis, so the devices itself, and that's a question of scale. What I've been told.
I fully support that view that this is about the scale, and you see also prices of renewable solar, wind, and also it's like typically here in Norway when you have really surplus of hydropower. The cost, so the problem always is actually the storage and the logistic cost. How to get that from a location where you have the renewable energy available and you have surplus, because that will be very cheap. But how to store it and bring it to the bunkering flange of the ship.
Mm-hmm.
Yeah, that's very true.
Okay, we have to end our discussion. I think it was a very lively and very interesting discussion. I'd like to ask you for your closing remarks. Optimize 30 seconds per person, please. Who is going to start? Marco?
Yeah, I can start. Hybridization, electrification, it's great, and I'm looking forward to do this also in the marine industry. I did it 10 years in the automotive industry, and now, my aim is, I said always, I come towards voice to electrify everything what's not cars. So marine is one of this. So, and I'm happy to do it with all you together, because as we heard, we have to do it together. And we would like to be the system integrator. That is what is our passion versus power systems. And so we need the shipyards as our clients, but you need also component suppliers from Gaia, also WinGD maybe for simulations and so on. We have to work together to bring this to success.
Stefan.
Yeah, we believe that many of the ship types can be currently with two-stroke engines, and can be hybridized, or actually more correct is to say that their degree of electrification can be increased. What is important is, in our view, the whole electrification, the efficient system lays on 3 pillars. The first one is the topology and the right sizing of the components. The second one is the control strategy. And the third one is the life cycle management. This is where the digital technologies come into play, so that we can feed back what is happening on board. We can fine tune the digital twin. We can dynamically alter the the system energy management on board when needed. Depends on the area of sailing, of cargo capacity utilization, and many other boundary conditions. So it is an exciting journey for shipping. I have been for quite some years here in this industry, and I can't recall such times. So I'm looking forward to work with many partners to increase the pace of hybridization in merchant marine, because I think there is a very good chance to do that if we do it right.
Okay, now we have 2 minutes. Yaya, and the rest, please, very short.
I will do. I say that my closing remark that electrification hybridization will just increase, and I think you can do this will be applicable to all kind of vessels. You need a big portfolio of different batteries, because the requirements for the battery side is different from vessel to vessel, and battery is the enabler for all kind of alternative fuel system in the future. So that's all for me. Thank you.
Thank you. Erik Jan?
Yeah, I think the discussion of system integrator, who is the system integrator, will stay. But in the end, we all have a common goal, and that is becoming more sustainable. So let's unite and make that happen.
Okay. Morten?
Thank you. I think as a problem is clear now, I think hybridization and electrification has a large future in shipping. but we need to bring the transparency to the table, so the decision makers feel safe in going this direction, and that's by system integration and providing the right tools, but it's also by seeing some of the examples and providing insights in how these examples are working in real life. And I think once we get the ball rolling, then we will see this becoming a larger part of the future vessels.
Thank you, Morten. Yeah, I think it was a very good and interesting discussion. We touched a lot of interesting topics. I hope it was also of interest for the audience. I think very clearly comes out standardization, modularization is very important. And there is a lot of work to be done in the next years to achieve the goals until 2030 for a broad range of different types of vessels. Thank you very much, and have a nice day to all of you. And thanks again to the panelists.
Thank you.
Thank you.
Yeah,
Thank you.
Bye.
Yep.
Bye.